Welcome aboard. This is the MATLAB coding course series titled How to IMU Part 3 of 3. I'm your instructor Steve, and you know how I got my nickname by now. This series starts with a question: how do I live plot my IMU data? The problem that you'll encounter is that we need a live stream and a live plot code. We need two separate types of script that need to be combined into one. In section 2, we did the live streaming code. Now we need to create a live plot code. The solution to that problem is that we're going to break it down how to live plot your IMU data in MATLAB right now. The objective for part 3, we have just one objective, and that is to live plot the IMU data for 10 seconds. The required hardware, the required software, and the required circuit layouts are discussed in parts 1 and 2. As you can see, I already have my 3 variables declared here, and if you don't know what I'm talking about, it's because you tried to go for section 3 without watching parts 1 and 2. Nice try, but they're worth a watch. The 3 simple rules in the coding core we have: 1, do not rush towards failure; 2, slow is smooth, and smooth is fast; and 3, make sure to drink some water. Okay, I'm going to call this session to order. I want you to activate your brain housing group. I want you to open your long-range visual scanning portholes, and of course, engage your primary weapon system. Here we go. Objective 1, live plot IMU data for 10 seconds and make it look like this, each with sensor with its own legend. Okay, sounds like we're looking for this right here. We've been talking about it. Okay, this is going to start with a new command, and that new command is going to be a tiled layout. The tiled layout is going to have 3 rows and 1 column. 1, 2, 3. We are going to say next tile. Our next tile is going to contain the accelerometer X, Y, and Z. So we need to create some new variables here. How about an ACC X line is going to be equal to an animated line? Let's go ahead and highlight ACC X line because we're going to be using it a lot. And we'll give ourselves some space here. The ACC X line is going to have a line style. And that line style is going to be solid. The ACC X line is going to have a line width, and that is going to be 2. The ACC X line is going to have a color, and we're going to use color matrices for these so that if we want to change them in the future, they'll be easier. We're going to go 0.99, 0.01, 0.01. That'll give you a nice red line to start with. Okay, and then we're going to talk about the ACC X line. Title is a new variable, which is equal to title, and that's going to be accelerometer. Accelerometer with a font size of 11. Nope, you get one too. Okay, good. Next, we're going to talk about the ACC X line. New variable X label is going to be equal to the X label command. And the X label is going to say time in seconds. Next, we're going to talk about the ACC X line. X label font size is going to be equal to 9. And following that, we are going ACC X line Y label is going to be equal to the Y label command. And that's going to be accelerometer. It's not time. We're going to be talking about it as acceleration in G's. Last time we did the meters per second squared, but now we're going to do it in G's. And that can go ahead and close out. And then we're going to talk about the ACC X line. Y label has a font size that's equal to 9. Good. Then we're going to say set GCA. This is another new command for this section. This is going to set the GCA color to the following matrix. That's going to be 0.45, 0.45, 0.5. It's going to give us a nice charcoal gray background. What we're looking for, that's good. We're going to say put the grid on because I want the graph paper in the background, and hold on. All right, so let's go through this really quick. We have a tiled layout. Our next tile, which is really our first tile, is going to be the ACC X line as an animated line. That line is going to need an axis to travel on, and I'm going to say 1 to 100 because we're doing 10 seconds, And since I'm measuring in G's, I'm going to go from 0 down to -3 or as high as +3. Geez, I don't think I'll be able to pull any faster than that from this seated position. So let's go ahead and check this out. The axis looks good. All of our properties look good. So you can go ahead and highlight everything to do with the ACC X line, copy it, paste it in, and now we're going to talk about the ACC Y line, which is going to be all the same properties as the X line, except for the color. We're going to want to differentiate a little bit, so let's go 0.35. We'll make that a little more of an orange color. All right, and then we can jump in here, put it in again, and now we'll talk about the Z line. That is also going to have a different color profile, and we're going to go 0.70 for that one. Make it even brighter orange, easier to differentiate from the Y and the X lines. So here we are, we have our axes consistent, and the accelerometer animated lines are all set. So we're going to continue with a hold on statement, and then we're going to create a new variable called the ACC legend. And that is going to be equal to the legend command. And of that legend, we're going to be concerned with the ACC X line, the ACC Y line, and the ACC Z line. Those three lines are going to have the following titles: X-axis, Y-axis, and Z-axis. Great. We can suppress that out. And next we're going to start talking about some of the properties to do with our legend. So let's go ahead and copy that. Our ACC legend is going to have a font size of 12. And then our ACC legend is going to have a location, and that is going to be equal to north, east, outside, because I don't want my legend encroaching on my animated lines. So let's put it outside. And then we're going to say that that ACC legend is going to have a certain number of columns, and it's going to be 1, so that my X, Y, and Z are stacked on top of each other. And then we're going to say that my ACC legend is going to have a text color that is going to be equal to just white, because we're doing charcoal gray in the back, so white text will look nice over that. Then we're going to say the ACC legend is going to have a title with a string that says Accelerometer data. Good. Suppress that, and then our ACC legend title string is going to have, rather, not the string, the color of that string is going to be also white over charcoal gray background. And then the ACC legend font size, that's what I was saying before, the title font size. Title font size is going to be equal to 11. Okay, and then now that we've declared our legend with our properties that we want, we're going to say hold off. So this whole section we just made, the accelerometer X line, the Y line, the Z line, and the legend, is going on to our first tile. So since we've declared our hold off, we can go ahead and say next tile. The next tile is going to be the gyroscope X, Y, and Z. So what I want you to do is go ahead and highlight everything from the accelerometer X, Y, and Z, and copy it, and let's go ahead and just paste it in on the gyroscope, and let's start running a comb through it from the top down. Okay, let's say this is not an ACC X line, it is a gyro X line. It is not an ACC X line here, it is a gyro. This is also all of them. Gyro, 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 and gyro. What we need to reconsider is the axes limits. These are going to be coming in radians per second. So let's go ahead and make that -10 to 10. Okay, and we'll be talking about a different color profile for these. Let's go 0.01, 0.0, let's go 0.01, and then 0.99. Okay, very good. Now let's go ahead and check out our properties here. They all look good. It's not going to say acceleration, it's going to say angular velocity. And it's going to be in radians per second. It's not going to say accelerometer, it's going to say gyroscope. Okay, everything else looks good. So let's go ahead and carry on to our next one. That's a gyro Y line. That's a gyro Y line. That's a gyro Y line. That's a gyro Y line with the color of 0.01, 0.31, and 0.99. And next we're carrying on to our title is a gyro title that says gyroscope. And carry on to the X label, Y labels, our gyro variable names. And our gyro Y line is going to say angular velocity in radians per second. And finally, that will be another gyro there. Otherwise, we're good. Let's not forget about our axis. Up here was -10 to 10. Now we're talking about the gyro Z line. Goes from -10 to 10. This is not an accelerometer anymore. It is a gyro. This is a gyro. This is a gyro. We're going to change color profile. 0.01. We went 0.031 last time. Let's make that a 3.5. And let's make you a 0.7 and you are a 0.99. Very good. Carrying on, the gyro Z line, gyro Z line X label, gyro Z line X label font size, Y label font size. It does not say accelerometer, it says gyroscope. It does not say acceleration, it says angular velocity in radians per second. Alright, now we're going to move on down here and let's talk about our Gyro Legend. Do not do the shift enter here or you'll lose everything. Okay, you'll have to redo it all. So let's just keep manually punching through. And that is not going to say accelerometer data, it's going to say gyroscope data. And it's not going to be the ACC line, it's going to be the gyro X line, the gyro Y line, and the gyro Z line. X, Y, and Z titles are fine because we're declaring it as the gyroscope right here. And that should be it for our gyroscope. So we can go ahead and say next tile. Oh wait, I just did them all backwards. That's funny. So let's go ahead and just highlight all the gyros. Use guys. Don't go there. You can go away too, and so can you. And you can say accelerometer. ACC accelerometer. Okay, we have ACC X, Y, Z with our legend, and let's just go ahead and say gyroscope. X, Y, Z, and I'm just going to paste what I just took out there, and we are back on track. Our gyroscope, and we're going to need a little next tile right here. Next tile. Good. Gyroscope, X, Y, and Z lines. Defined. Axes are good. Gyro Legend is good. Let's get our next tile in order. Magnetometer. Alright, for this one, let's do this correctly. Gyro has 4 positions. ACC only has 3, so let's go ahead and grab all of the ACC stuff again. Let's copy it, and we'll bring it on down to the magnetometer section. We will not need a next tile because this is our 3rd tile, but let's go ahead back up to the top where it says magnetometer, and let's start changing out some variables. We have a mag. Let's see if we can do it faster this way. Just copy that. Paste. I don't want that thing keep popping up. I'm not going to do it. I'm not going to shift enter because that would ruin everything. I'm just going to pick them out where you decide not to pop up. Can't pop up everywhere. Let's talk about the axis on this. This is a magnetometer coming in microteslas. We're going to need to go to 120. And it's not going to say accelerometer, it's going to say magnetometer. It's not going to say acceleration, it's going to say magnetic field. And that's coming in micro Teslas. And then we can go on down to our mag. Y line is also an animated line. U again, my little pop-up friend. There has to be a way to get rid of that, because this one actually went out pretty smooth. Very good. Does not say acceleration, it says magnetometer. Does not say acceleration, it says magnetic field. And it's coming to me in micro Teslas. The axis is going to be negative 120 to 120. And I feel like there was something else that I was missing. I was just thinking, oh yeah, the color profile. Okay, 0.01, 0.99, and 0.01. That should give us a nice differentiated color, right? Yes, very good. Okay, let's go in here. It's 0.01, 0.99, and 0.35. Good. Okay, that's the mag Y. All set. Magnetic field, Tesla's okay. Now let's go in here and let's talk about the mag Z line. There's another animated line. It's going from 120 to 120, and now we need to do some eliminating. Wow, this one's great. That little pop-up thing is not getting in my way at all. Let's talk about the color profile, since I forgot it last time. 0.01, 0.99, 0.70. It does not say accelerometer, it says magnetometer. It does not say acceleration, it says magnetic field. And that's coming to me in micro Teslas. The GCA is good, the hold on stands, and now we're just going to go ahead and redefine the Mag Legend, not the ACC Legend. One more, last but not least, we come up here to make sure that our legend is containing the proper animated lines. They can still say X, Y, and Z. Let me double check my gyroscope is good. Gyro X, Gyro Y, Gyro Z. And up here we have ACC X, ACC Y, ACC Z. Okay, great. Now we have our tiled layout all squared away. So we can go ahead and hit it with a hold off. And now we're going to start creating the loop. Let's go ahead and say IMU count is equal to 0. IMU data is equal to an empty matrix. Now it's loop time. While IMU count is less than 100 for 10 seconds, I want IMU count to increase by 1. Okay, while that's happening, we are going to establish home base. Home base includes a variable called IMU read, which is equal to read the IMU. We're going to read the IMU, and then we're going to create a new variable called IMU Matrix. IMU Matrix is going to be equal to the IMU read just as a matrix. Then we are going to take the average of that matrix with a variable called IMU mean is equal to the mean of the IMU matrix. That's going to narrow them down into single scalar values for us. That's going to need a little something right there. And home base is all set. Next, let's go ahead and talk about the accelerometer. The accelerometer, ACC x in meters per second squared, is going to be equal to the IMU mean of the first column. Let's go ahead and highlight that. We can copy it. We'll paste it in twice. We're going from 1, 2, 3, 4, X, Y, Z. Very good. I was talking about doing this in g-forces, so let's make some new variables. ACCXG is equal to ACCX meters per second squared divided by 9.81. That'll tell it in g-forces instead. So we can go ahead and copy that one, paste it in twice. ACCXYZ, XYZ, ACCXYZ, Z, only Z. Good. Okay, accelerometer is all set. Let's talk about the gyroscope. Gyroscope is coming in radians per second. Let's talk about gyro x radians per second is equal to the IMU mean of all of the fourth column. Let's give ourselves some breathing room here. Once you go ahead and highlight that one, you can copy and paste that in 2 times, and we're going 4, 5, 6 for x, y, z. Now it's coming in radians. We said that was okay, but let's say you wanted to change it out. You could do gyro x degrees per second is equal to gyro x radians times 180 over pi. Go ahead and highlight that, copy it, paste it in 2 times, and we're talking about gyro x, y, z in order to produce degrees of x, y, and z. That's great. Everything is suppressed. We are all good there. Gyroscope is all squared away. Moving on, we are talking about the magnetometer. The magnetometer x is coming in microteslas, and that's just fine. So we're just going to say IMU mean all of them in the 7th. You can go ahead and highlight that and paste it in 2 times. We're going 7, 8, 9 for x, y, and z. Good. Magnetometer is all squared away. And not that we're going to use it, because we're really only talking about streaming the sensor data here, but if you wanted it, you could grab your orientation out of this, and you would do that by saying ORTX in radians is equal to the IMU mean in the 12th, because it's ZYX, okay, 12th. And then you can go ahead and copy up there, paste in 2 times, and 12, 11, 10, because it's ZYX in the initial table, okay? Go ahead and put that in your radians there, and you're going to want to convert it into degrees perhaps, so we'll say orientation x degrees is equal to orientation x radians times 180 divided by pi. Go ahead and suppress, and then we'll copy, paste it in 2 times, and we're talking about the orientation y, the orientation z, in order to produce degrees of x, y, and z. Good. The entire IMU, in terms of its motion capacity, is caught in these commands here. That's our data capture section. Now, I'm going to pull that IMU data matrix back in here, and I'm going to say that it is going to be the matrix with the following columns. The first column is going to be the IMU count. The second column is going to be the ACC X in G's, and then the ACC Y in G's, then the ACC Z in G's, then the gyro X in radians, followed by the gyro Y in radians, and then the gyro Z in radians, followed by the mag X, mag Y, and mag Z, all in microteslas, which is good for me. And then I want my orientation in degrees, so ORTX degrees, ORTY degrees, ORTZ degrees. This will be a good example to show you how you can pull radians of one and degrees of the other, and it's really not a big deal. I suppressed that matrix because I don't need to see these iteration counts compiling on top of each other over and over again. But this part here definitely is the silent data capture. And then we're going to say what I will see in the command window. That's going to go with our Show Me Now series, so that's going to be Show Me IMU. IMU is equal to a new matrix that contains everything except the IMU count. Let's not be greedy here. Let's just grab what we can. Good. We'll go ahead and copy those variables and drop them right into Show Me Now. We'll close it off and suppress it because we don't need to see Show Me Now equals each time. We're just going to display the data instead. So how about you just show me what's going on with that Show Me Now variable instead. Solid. And now it's time for a loop condition. If my IMU count is equal to 100, then I just want to go ahead and display this is the end of the IMU session. And that will terminate my loop for me. So that's solid. We can end there. And normally we would just end the loop and then grab our IMU data. We would make our IMU table as array to table of the IMU data with the following variable names. Those being, well, we had time in 0.1 seconds per iteration. Then we had ACCX, we had ACCY, we had ACCZ. That was our accelerometer. And then we had a Gyro X, we had a Gyro Y, and a Gyro Z. That was our gyroscope all set, followed by a Mag X, Mag Y, Mag Z. That was our magnetometer, followed by orientation X, orientation Y, and orientation Z. Good, those names are good. We're going to go ahead and unsuppress the table because we do want to see it when it's all said and done. But now we need to use some more of those other commands. If you watched part 2, you're saying, wow, this from here down, from 344 down, it's identical to part 2, and you would be absolutely right. But we have these things here, these animated lines, these big commands, these big blocks of code. What we need to do is call those variables into the loop by saying, I want you to, come on. I want add points. I want add points of the ACCX line to go along the x-axis of the IMU count and the y-axis of ACCXGs. Okay, you can go ahead and copy that line. Paste it in twice. You're going ACCY line, ACCZ line. You're still using the IMU count for the x-axis, but your y variables are going to be ACCYG, ACCZG. Okay, next we're going to add points of our Gyro X line along the IMU count for the x-axis and the Gyro X radians for the y-axis. You can go ahead and copy that one. You can paste that in twice. And we're talking about Gyro X, Y, Z, followed by the lines have to be also X, Y, Z compatible. And let's do this one more time. Add points. Add points. Have I been missing an S this whole time? Add points. Do not rush to failure. Add points. Okay, that is add points of the Mag X line to the IMU count for the x-axis and the Mag X in microteslas for the y. That's very good. We can go ahead and highlight that, and you can paste that in 2 times. We're talking about the Mag X line, the Mag Y line, the Mag Z line in our microteslas of X, Y, and Z. Okay. Let's just go ahead and put the icing on the cake here and say draw now. And do a little spacing here. All right, let's take it from the top. We're going to run a comb through this script real quick. Starts with the tiled layout, 3 rows, 1 column. First tile, next tile. ACC X line is an animated line from 1 to 100, negative 3 to 3. It has the following properties. Hold on. ACC Y line is an animated line from 1 to 100 and negative 3 to 3 with the following properties. Hold on. There's an ACC Z line is an animated line from 1 to 100 and negative 3 to 3 with the following properties. Hold on. I want a legend for my 3 animated lines with X, Y, and Z axis labels. I want the legend outside with the other following properties. Hold off. We're done with tile 1. Next tile, gyroscope, X line, Y line, Z line, negative 10 to 10, negative 10 to 10, 1 to 100, 1 to 100. Properties are all squared away. We've changed the name and the Y label value. Negative 10 to 10, very good. The legend, gyro lines in the legend, very good. And next tile, magnetometer, animated line, X, 1 to 100, negative 120 to 120, the following properties. Magnetometer Y line, negative 120 to 120 here, 1 to 100 here, following properties. Magnetometer Z line, 1 to 100, negative 120 to 120, and the following properties. Magnetometer legend, very good. Does not say accelerometer data, it says magnetometer data. Gyroscope data, very good. Okay, hold off. We are all done with our tiled layout. So we're starting a new variable. The IMU count is 0. There's an empty matrix here called the IMU data. While the IMU count is less than 100 iterations, and we know it's running at 10 iterations per second, I want the IMU count to equal the IMU count plus 1. So we're going to get 100 iterations over 10 seconds here. Home base is the IMU read variable, which is equal to read of the IMU as a table. IMU matrix converts the IMU read table into a matrix. IMU mean takes the average values of all the columns in the IMU matrix and produces scalar values. The accelerometer, x-axis in meters per second squared, comes in the first column, the y and the z in the second and third, respectively. We're going to convert them over into g-forces by dividing their meters per second value by 9.81. That covers our accelerometer. Next, the gyroscope is coming in radians per second in the 4th, 5th, and 6th columns for the x, y, and z axes, respectively, and we're going to convert them into degrees by multiplying them by 180 over pi. Next is the magnetometer. It comes in columns 7, 8, and 9 as x, y, and z, respectively. That's all in microteslas, and we are happy with that. Finally, the orientation comes in the z, y, x. Z, y, x. So it's going to be 12, 11, 10. I mean, even if you didn't listen to anything I said, you would get the y-axis correct, but then you'd be very confused when it came to these two parts here. So ORT x radians is coming in as the 12th column. ORT y radians in the 11th. ORT z radians in the 10th. And then we're going to create new variables in degrees, and we're going to multiply the radian values by 180 over pi. Next, we're going to do a silent data capture. That is our empty matrix that we declared at the beginning. IMU data is going to be equal to a matrix containing the following variables. This includes the counting variable, the accelerometer x, y, and z in g-forces, the gyroscope in x, y, and z in radians per second, the magnetometer x, y, and z in microteslas, and the orientation x, y, and z in degrees. Now, as that's silently capturing everything that this IMU is doing, we're going to create a show me now variable, show me IMU, to show me what I'm going to see in the command window. That's x, y, and z accelerometer, x, y, and z gyro, x, y, and z magnetometer, x, y, and z orientation. I don't need to see show me IMU equals every time, so I'm just going to say show me IMU. Display show me IMU. Now, if the IMU count gets to 100, you'll display this is the end of the IMU session, and our loop will terminate. And before it carries on to the end, we're going to add our points from our animated lines. X, Y, and Z accelerometer, X, Y, and Z gyro, X, Y, and Z magnetometer. All of them will carry on. The IMU count is the x-axis, and they have their corresponding X, Y, and Z values to associate with the y-axis here. The last command is draw now. That brings these sections that are tied to our sections at the beginning to life, and then we're going to end our loop. At the end of the loop, I'm going to capture that silent matrix again and convert it to a table. We know that drill there. So let's go ahead and shrink this down. Let's see, I made a little housing for my IMU. Let's go ahead and give this a run. When you run that section, a figure is going to pop up. And let's just go ahead and move it over here a little bit. And you are going to get some lines. And you're going to get some data. Let's take note of one specifically. This orange line here. This is my accelerometer z-axis. If I just let that go for a second and then invert it, you can see how it switched from 1G down to negative 1G. Okay, and then I can flip it back over and we can get back to doing some wild. Okay, let me go ahead and blow this up. If you make the graph here bigger while you're streaming the data, it can come in a little more choppy. Maybe sometimes you can reset your computer to make it run a little faster, but I find that just keeping it at its original size is pretty good for the meantime. But go ahead and look again right here. We are right on the money right here. 1G when I was holding it nice and flat, then I flipped it over and we're right on the money again for negative 1G. Our calibration is dead to rights right here. So let's go ahead and check out the other ones. We have our gyroscope lines and our magnetometer lines. Let's just go ahead and bring this up. Let me check out what's going on in my command window right now. Wow, this is a lot of data. This was our first iteration here. We had our accelerometer X, Y, and Z. We had our gyroscope X, Y, and Z columns. We had our magnetometer X, Y, and Z. And we had our orientation in degrees X, Y, and Z. Now remember that third column should be coming in at about 0. It should be just about 1.0. We should be right on the money there. So we're right in the ballpark. And then as we keep scrolling down, 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 all these iterations went through. So we got a couple. Oh, I got 2. 2.22. That's incredible. I must have been moving pretty quick. At the end, it says this is the end of the IMU session of those 10 seconds, and then it produces this table for us. This is much better for presentation right here. I have all of my data, all of my everything here. It's all right here. And let's say I think you can dock the figure if you want. You can just click that. It'll set the figure right into your primary workspace. Okay, let's go ahead and clear that out. Let's go ahead and clear the command window. Let's open this up. And just for fun, we're going to execute one more little section right here. And that's going to say find max acceleration z-axis. Let's go ahead and say max z ACC index is equal to max of ACC, I'm sorry, it's the max of IMU data in all of the third. What do we got? Let's see where we had the maximum z-axis acceleration. That occurred in the 99th index. So if I go ahead and pull out my table again, oh wait, I made a boo-boo. It's not the third, it's going to be the fourth because it has the counting variable in it. Clear. Show me the index. There we go, index number 98. Okay, so if I pull up my IMU table, I'm going to get that nice big table again. 1, 2, 3, fourth column. Okay, that's correct, and we're looking for the 98th index. Sure enough, there it was. What did I say before? I pulled 2.2235 Gs. So I'm a little dizzy from all of that. But I hope you've enjoyed this series, and that is how you live stream and live plot your IMU data in MATLAB. We'll see you next time.